It's got a bunch of clients. It's been around for about 5 years, and I want to talk about the iOS client that I've been building with it and what we're doing with Scuttlebutt, and then sort of more broadly where Scuttlebutt as a platform is going. And so I'm going to switch here to my slides. And so what I want to talk about is this idea that where we're at with social media. I've been building social media applications for a long time. The current Black Lives Matter protests in the United States reminds me that I first did a live stream from a protest with lots of tear gas back at the WTO protests in 1999. And so at the time, we just wanted to build a way in which people could publish online. And through that work, I was the first employee and the lead developer at a podcasting company, Odeo, which famously pivoted to become Twitter. And there was a faction of us within Odeo and Twitter who wanted it to be a protocol and wanted to be open and wanted to be more decentralized or federated. And eventually that wasn't the path that Twitter as a company took. And so I've been with a community of folks looking at how do we build something that is decentralized and gives you sort of the values of the open web. And that's sort of what we're doing with Scuttlebutt. So on a bunch of social media, I'm Rabble. Back in the 90s, there was this idea that the digital world would be independent. But what we discovered was that it also brought in all this sort of antisocial behavior. And so simply by liberating ourselves from companies and government regulation, it didn't necessarily create better behavior. And so we had the governments intervene sort of to establish control and regulate the digital world. And we had companies build what are essentially digital media shopping malls. You can go in, you can create your account, but you don't own your account, you don't own your identity, and they have an opaque legal system that decides whether or not they delete your account. And we have lots of debate about whose accounts should be deleted or shouldn't be deleted. And so that becomes a major issue. So social media is this sort of tense conflict between regulation by the state, which we see in places like China, and regulations by corporations. But what we don't have is sort of the social distance and structure needed to have healthy conversations. And so what we're doing with Scuttlebutt and Planetary is we're saying what we need to do is we need to think of this space we're creating as a commons, a space for community self-management, where users own their data and identity, where creators can charge for content. It's a space where commerce can happen, but it's not run and regulated by a single central authority, where there's end-to-end encryption, including metadata, so you have privacy, where users can hack on things to build new things without permission, and you can have a sustainable economic system around it. And so those are the values we're trying to build into this future. And if you look at what makes a commons work, it's where you have clearly defined group boundaries, where you can match the rules, where you can sort of do all of these things that sort of make things well governed. And if you have these structures and norms within a commons, they work well. And if you don't have them, then they get overrun and destroyed, and you get sort of the tragedy of the commons. The tragedy of the commons is actually a apocryphal argument created by neoliberals to argue that we shouldn't have community-governed economic resources. But it's not based in any kind of reality. And if you look at a Nobel Prize-winning economist, Ostrom, she actually studied what makes commons works and realizes that huge parts of our economy and our society are run this way. We just haven't given it words and names and acknowledges it and valuing it. So I think we can make our digital social media ecosystem this same kind of thing. And to do that, we built a social media application that's built on an open protocol that supports privacy, that looks very, very similar to the existing things. And the goal was to make it feel like Instagram, Tumblr, Twitter, Google Reader, something that people didn't feel was foreign, but where the ability to speak and the control of it was run from your devices. We're building a larger ecosystem, so there are dozens of different Scuttlebutt clients that speak a compatible protocol and communicate with each other. And that's sort of centrally important to making the promise of you're not dependent on a single application. And so Scuttlebutt has a very weak center in terms of the community of development. There's not a company behind Scuttlebutt. There's not a single reference application. There's many applications and many companies or communities of people who are building these things. Scuttlebutt's flexible. We've built a whole bunch of weird applications. We built SoundCloud sort of clones and an social NPM library and a version of GitHub on top of it. But the primary use is sort of more normal social applications. And some of the central features of it is it's decentralized, it's permissionless, it has a social feed of structured data, it uses JSON for the structured data, and it's an append-only log where each post is cryptographically signed. And so it supports a gossip protocol. So I write to my log and I connect to peers, and that signed data will then get passed on to other peers as they request it. And so you can work offline, and as long as you occasionally sync with someone else, your messages get passed on to others. And so it alleviates the need for central servers or nodes the way something like Mastodon might work. And the way it works under the cover is sort of a social database. It's based on some of the ideas from CouchDB and a Kafka design pattern, where each user will have some set of the data. We call it subjective, based on who else they're seeing and where they're coming from. And so no one has a universal view of the entire ecosystem. And each person writes to their own log and then references other people's logs. And so you can construct social software on your local database based on multiple people having write access to sort of vertical slices of your database. Users' identities, similar to how they work in the matrix world, they're a cryptographic key pair. They're not registered. You don't have to register them to a server. There are a few identity servers, but they're not as widely used as in matrix. The identity is a public-private key pair. Probably everyone on this talk sort of understands that. And because it's a key pair, you can take your identity from one Scuttlebutt application and move it to another, and it reconnects to the network and downloads your log and downloads the logs. And from that, discovers who you're following and who you're connected to and starts reconstructing the content. And this is super important because it means that users are able to move between applications and they're no longer dependent on the decisions of a single application creator. The peers exchange lists of identities and where they've connected to. So you can connect to people over Tor, Yggdrasil, or Scuttlebutt nodes that do followbacks on sort of known fixed IP addresses. It also supports connecting over sort of Bluetooth and mesh Wi-Fi if you're local to someone else. And each time it does a key exchange to make sure that you have relationships with the person you're sharing data with and who they are. Most people use TCP/IP, but we support a bunch of other ways of routing messages. This is what a Scuttlebutt message looks like. It's JSON. We have a couple other feed formats that are coming out that use CBOR because it's more reliable and consistent about its signing. But the content part, as you see in the content hash, will stay JSON because it's flexible for people to build applications on top of. One of the tricky parts of Scuttlebutt, and something some people in the community have been reconsidering, is that it's a very strict append-only linked list data structure. And so it gives you some advantages of you being able to pull someone's feed and know precisely what they've said, prevents falsification of messages, but it makes the content deleting, editing, and ephemeral content quite tricky. And as we're building social applications, we've discovered that those are really important. Here's just another way of looking at what the append-only structures are. You simply sign the new message and include the hash of the previous one. We have some ability to evade censorship, and some of the clients by default route all the connections over Tor and a bunch of other systems. But even if you don't do that, the the message protocol is encrypted with the handshake so that you can't eavesdrop on the messages. The messages flow between different users. So here you can see a new user might connect to a pub and then they would start receiving messages from other people. And so each person's perspective in the application is a bit subjective. I like to think of it as if you're in a forest where each tree is a user in the application, and you have a bright light at night and you can only see a certain distance of trees around you. And so to connect to someone farther away, you need to find that intermediary node. And you can relay to each person you're connected to who you're interested in, and they may or may not be able to flow the messages back to you. Scuttlebutt, the default implementation is in Node, so you can just go, npm install Scuttlebutt, and then that'll let you open it. There's working implementations in a bunch of languages. The one that we use is in Go. There's Rust, Elixir, Haskell, C, Java, and a bunch of others, but most people either use Go or npm, or the Node one. Your secret is just literally a JSON hash with the information, which means it's really easy to copy around and collaborate. And the publishing methods work from the command line so that you can sort of see what's happening and how it posts. And you can either communicate via the command line or via a whole set of libraries to append to the logs. And then when you connect to a node, you just do a command of like create user stream or create user history, which gives you an array of JSON objects that you can then build social applications on top of. With the encrypted messages, you just get a content hash with no description of what it is. And then the way it works is you attempt to decrypt every encrypted message that you come across. And it turns out that's actually not that hard. The advantage is that you don't have any leaking of who the recipients are for these private boxes, for these private messages. And the first message in the encrypted messages will be the keys for people who are participating in that thread to be able to all write the same set of private encrypted keys. Scuttlebutt right now has a few major problems: delete, data storage, editing, authority, user discovery, and abuse. And we've been working on trying to figure that out. One of the things that I think this is a discussion that's happened a lot with Signal and Matrix and Scuttlebutt is decentralization doesn't always mean better. We have to look at the software we're building and see, does it make the world better? Does it work better? And how do we have a positive effect on the world? And so one of the central aims and things that we've talked about as we design Scuttlebutt is that we have a design justice view for how we're doing it, where we look at the benefits of burdens, what's fair, how do we make fair and meaningful participation in design decisions of the platform. And so one of the things we've done when we've had developer meetings is that we made sure that we had not just developers there, but a bunch of different communities that we intend to serve and work with, participating in the design and direction of the protocol and the applications. To do that, we laid out a series of principles. So we have principles for society. We believe in inclusion and pluralism. For the community of people creating it, independence, subjectivity, interdependence. The technology we're building, that it's local first, you can upgrade it, you can do socially near modifications, and there's multimodal ways of getting into it, and environmental values of sufficiency, efficiency, and abundance in the platform. This is the first meeting of the Scuttlebutt developer community. It happened about a year ago in New Zealand, and it was a sort of a super powerful way of mixing the developers and the users of the platform to try and sort of drive it forward. Out of that, we came up with an idea of looking at all the horrible things that could happen on these platforms. And we wanted to be intentional about it. And so we found out and we analyzed social media about all the ways in which targeted harassment happens, how we can defend it, and how bad it is, broad scale harassment of how things are working, social friction between people, the role of capitalism, markets, and power in the design and the use of the platform, disrespecting of users' attention and attacks, user confusion, developer privilege and attention. So how do we privilege developers who are hackers to have a different level of ability to participate and take some action on that? when we do and don't want to copy the centralized sort of capitalist models of technology that we're developing, and how our system is encouraging the creation of antisocial behavior. So we do know that there's a group of Norwegian neo-Nazis that are using Scuttlebutt. They're blocked from the main network of what you're published and sort of connected to, but those blocks are an individual and on a pub level, and so it's important to understand that. And then a bunch of technical problems with scaling and making it work. It's potentially get very large feeds, and we need to deal with that, and sort of the process of finding connections is quite confusing. And sort of how do we make it effective for users' needs? And so we came up with a whole set of solutions for all these problems. And then we looked at it, and we said the problems we have on a high level is it's signed but not encrypted by default. We're going to work with that with private groups. Ordered logs can get forked and broken if you use the same identity on multiple devices without them syncing. The strict ordering in Scuttlebutt matters, but it might not in social software. The immutable data structures are problematic with no delete, edit, or ephemeral content. Handshake protocol is more difficult and different than HTTP, which makes implementation difficult. And it's problematic to just use the same key for long-term identity. And so we need to figure out how we solve some of these problems. One of the solutions is the private groups. We're quite close to rolling this out and building the front ends around it. It's been a major project for the last year. It doesn't yet do double ratchet encryption, so it's not perfect, but it's a first version. And it works without internet connections and scales. And then the new thing that I'd like to talk about is that we're working on this sort of idea of what would it be a rewrite of it. And one of the versions we're calling is EarthStar. Another one is a Pigeon protocol, where we say, what if we drop some of the features of Scuttlebutt and based on our evaluation of how it should be used. And EarthStar is sort of the most promising one of that. We've gotten a grant from Mozilla to develop this. It's like Scuttlebutt, except one author can use keys on multiple devices. The data is mutable. It uses a key value data store rather than the event streams that Scuttlebutt's been using. It supports partial replication and syncing over HTTP and not just the Scuttlebutt handshake protocol. And it has less strict guarantees about orders and data sets. So to understand it, it's like LevelDB, but multi-author and syncing, like CouchDB with signatures that you can have untrusted nodes, and like DAT or IPFS, but it's more social and mutable and multi-device in terms of being able to write to the same set of content. So with that, it's very quickly, I haven't been able to see everyone, but this is sort of a summary of it. If you go to planetary.social, you can get our iOS app. It's released under a Mozilla license. If you go to scuttlebutt.nz, you can find more information about the protocol. Planetary is currently on test flight in private beta. Apple requires us to have a bunch of centralized delete and blocking services that we're working on getting in place in order to be in the App Store, which feels weirdly contradictory to an open decentralized network, but it's sort of something we've just had to deal with. So I didn't have a timer on that, so
I think you might have hit 20 minutes absolutely on the nose, which is incredible, Rabble.
Yeah.
Thank you.
Yeah, thank you.
Perfect. All right, Rabble, thank you. We have some questions if you've got time to stick around and answer.
Absolutely.
So from the room, let's start with the platitude. So these slides have been great and explanations for what first-time technical users would care about. So thanks. So it's Christian. Michael Downey asks, is there a way for viewers to jump on the Planetary beta waitlist?
Yeah, so you can join on the waitlist by going to planetary.social. Also, if you send me a message in the Matrix chat, I'll just, with your email, or send me a direct message, I will send you an invite right away. Oh,
great. Oh, I'd like that too. All right, so I'm gonna go down to some of the more interesting questions. So Eigel is surprised to learn about the relationship between SSB and Twitter. I think that's not so much a question; it's just an exclamation that maybe not everybody knew about that.
Yeah. So a couple of us who were there, Blaine Cook and myself, have been peripherally involved in Scuttlebutt since its very early days, and sort of Blaine is involved with some of the design stuff. He's the one who created the Twitter API and the @reply and like really built Twitter. I was not as directly involved in the coding on Twitter. Some of the funding we've gotten is from Biz Stone, co-founder of Twitter, and Greg Kidd, who did much of the early work on Twitter. And so, and then we have, along with a bunch of other people, been involved with Twitter's Blue Sky to try and figure out what an open protocol is. And I would say, for the last several years, I've sat down with Biz and Jack Dorsey and explained why we needed a decentralized thing and how Scuttlebutt works and how they should be building something. And so I have a feeling that those continued conversations is part of why Twitter decided to go into the Blue Sky initiative, even though Blue Sky isn't Scuttlebutt. Those conversations in that sort of direction of what we're doing with Planetary and Scuttlebutt have been something that the Twitter executives definitely know about.
Right. So it's a background influence, background noise on the project. Yeah. All right. So let's get on this. Oh, so one from me. I think of everything in terms of event types. How does Secure Scuttlebutt work in that sense? Are there predefined event types, for example, for sending different types of posts?
Yeah, so there's the event type schema. We have a schema validator, and we have some examples of what event types are supported. Different clients can choose which event types they support. The strong convention is that the content field has a type, and you can either use a shared type between people, or you would, in that string, put your application : and then your subtypes. And so some applications use subtypes that are only for them, and some applications use it broadly. I would say there's nothing that breaks if you fail to follow the type conventions. So it's sort of, loosely joined, and but we do have types, and you can read about the documentation of them. And originally the whole feed was JSON, and so some of the applications do that and sign it, which is quite tricky for ordering. But what we're going towards is just the content field is JSON, and the rest of it is CBOR at this point.
Right. Okay. So mixing the content types.
Yeah.
Okay. So more questions. So possibly lower tech one. So question from Gray. What's been your experience of the wider community, wider Scuttlebutt community? Has building Planetary felt different from building an app that's entirely its own thing and doesn't interact with a wider community? This is a very familiar question to anybody using Matrix, but yeah, I'd love to hear an SSP response as well.
Yeah. So initially, it has the advantage of, similar to working on open source projects or free software projects, in that we're not dependent on only ourselves to build all this stuff. And so that's great. There's a larger community, and there's a lot of creativity and people building stuff. There's definitely been some coordination overhead around the whole thing, which is where we as a company build and implement stuff and put it out there, and then struggle with finding people who are not at the company to review and merge the pull requests, and differing priorities about how to do things. And so one of the things that's been held up is a new feeding coding format that uses CBOR. We call it Grabby Grove, that takes the content off chain. And so you can have much smaller feeds, more compact, and it's done and implemented in Go and in Node, but not in some of the other implementations, and not yet rolled up into all the applications. So if you use it, only some of the clients can see your posts. And so that's been a bit tricky. There was also, because there's no company at the center of Scuttlebutt, there's just a nonprofit association in France and another one in New Zealand, that what we have happening is there was a lot of distrust of a company. So Planetary has gotten some investor backing from Bloomberg Beta and Consensus and a few other people. And so there was a lot of fear that we would be taking it over. And initially we didn't open source the application, and that caused a lot of conflict, which is why we released it under a Mozilla license. Sort of properly take advantage of and support the community.
All right, thanks for the answer. Matthew, you got something?
Oh yeah, I was wanting to ask about EarthStar, because that sounds really interesting and quite familiar in some ways. And I was wondering what the underlying data structure proposed for it is. You said that it was moving to key value primitives rather than a log, but are they sitting in some kind of big Merkle tree, or is that still being defined?
It's still being defined. So I think right now it is a Merkle tree. But I don't know for sure. So what happened was Mozilla gave us a bunch of the people in the community grants, and rather than just trying to fix Scuttlebutt, we said, well, what if we experiment with what would we rewrite with everything we know now? And so EarthStar is maybe a third done. Like, you can install it, you can build it, you can sync, but we don't have any good social applications on top of it. One of the strong drivers that we've been looking for in terms of the Scuttlebutt community is we see a distinct need for something that is wiki-like. Like something that is not just a blog post, like where you have structured data and then you do data, and then what you see is a collaborative document that is subjective. So depending on where you are in the network, you may view the same document, but you draw from different people, and so you'll see a different version of it. And that's been difficult, and the ephemeral content stuff has been difficult, and the multi-device stuff has been difficult. So that's what we're trying to solve with EarthStar. Yeah,
no, it's doing free-form CRDTs would be really, really interested in that space, and I don't think anybody's quite nailed it yet. Should go and put scene graphs in and do a proper virtual world. It's not about the document trees; it's about the GL trees.
And our feeling is, when it fails, we'll just choose the most recent one.
Fair enough.
All right, I think we've got time for one more question. So Christian's asking about data retention in Manyverse. How do the data retention rules work? Does it ever clean up data? And does it protect popular content from being garbage collected, I guess you'd say?
So Manyverse doesn't delete data. Manyverse supports the legacy Scuttlebutt feed format, and so the data is there forever. There is a purge for the blobs, which are either longer form text content that's longer than 8K that isn't encoded in the main feed, or images or video. And so those are purged over time, or I think there's a purge button. But the content of the logs itself are there long-term and not deleted at all unless you block someone. And when you block someone, it goes back and zeroes out the logs for that person's content in your data store, so that you don't have a copy of it. So if it's content that you feel you would be illegal in your country or something else, that when you block it, it actually deletes it. But unless you block something, the content isn't ever deleted off your device.
Right. Okay. That makes sense. Okay, thank you. Thank you, Rebel. Thank you for being involved. Yeah, really nice presentation. We've got a whole load of people saying so and sending various emojis, which I assume are positive.
Awesome. I couldn't see the chat, but I'm going to go look at it as soon as we're done talking.
There's some other questions that you might want to take a look at.
Happy to.
Cool. All right. Thank you.
Thank you.
All right. So we have next. Thank you. We have Annie. Annie, thank you for joining us. I know you had to run away somewhere to get some more internet or something.
Yeah, we were staying out like in the country where my parents-in-law live, which usually has great internet, but the internet provider decided to work on the polls today, which was a great time for that. Wow,
that's really bad luck. Are you out hiding from the pandemic, or are you just on holiday?
Yeah, we have been staying with them since kind of the pandemic started, because in our apartment, we're basically in the middle of downtown, and so we don't have a yard or like really anything to
Yeah.
like sort of just get fresh air. So out there we have a big yard and 2 dogs to pet. So
nice. More dogs is a happy bonus, I think.
Yep.
So you are the developer, or the main developer anyway, of Ditto, React Native client, and you have a presentation, I think. So I'm going to let you do.
Yeah, so Ditto was sort of my brainchild. I'm going to go ahead and share my screen. Just like a little bit of background. I feel new to the Matrix community. All of this only started about, I guess, about a year ago now. And it started with a very little naive Annie being like, man, I'm really frustrated that all of my friends like don't like the same chat apps. I wonder if I could just like build one that bridges them all together. And so through some searching and just Googling, I came across Matrix and sort of just immediately fell in love. I was like, I should totally build something on top of this. And went through like 2 or 3 sort of versions that I've thrown in the trash before getting to Ditto. So today I made a little roadmap. I just wanted to talk about like sort of what's powering Ditto for those that like don't really know what's going on behind the scenes. Maybe you've just seen screenshots, but you haven't like looked into what is actually going on. And then like sort of my reasoning for why I'm using that and not certain other alternatives that I could be. And then just like a little talk about UX, just because like I like UX. And then a little bit about like the future and like where I see Ditto going. And then questions. So let's start out. What actually is like Ditto made of? So it's built with React Native. React Native is it's very similar to React, both of which were created by Facebook. So React Native was initially released in 2015, 2 years after React. And for those of you that like have experience with React, but maybe not React Native, they look very similar. So here are 2 examples of Hello World apps. On the left is React Native and on the right is React. And you can see that in React Native, you don't have the div and paragraph tags that you have like with HTML and JSX. You have views and text. What that basically means is these views and texts are rendered to whatever tags are used like for whatever platforms. That's why React Native is cross-platform. So for iOS, it renders a particular thing, and for Android, it renders a particular thing. But I compare these 2 right here to show that like they're really similar, and like it's cool to see that a web developer could really easily hop over and start being productive in a mobile environment. So why did I choose React Native? I already said like a little bit of why I chose React Native. I actually like just fell in love with React Native. This was about like 3 or 4 years ago, and I remember it so clearly. I was Googling like things in class in my program because like of course I was, and in the middle of class, I'm like, I already knew about React, and I was like, how can I build like iOS apps on like Windows, because I had a Windows at the time. So I was just like searching stuff like that. And I came across React Native, and I kid you not, I started crying because I was like, this is exactly what I have been wanting. And as a React developer, it was amazing to see that like, this is like what I'm used to, but I can literally create mobile apps. So my first point is just that I just love React and JavaScript. The second reason I love React Native and why I am confident in using it is because it uses native components and not web views. Early versions of React Native actually did use web views, and it gets a little confusing because there is a component in React Native called web view, but what that does, it's sort of like an iframe, and so it allows you to like pass a URL to it and it will show a web view in React Native, but at least for a few years and in the like new versions of React Native, it's really native components. And I actually found a really cool like graph to show this. I linked to it's from a Medium article I found. So I linked to that down there, and I can share like this slide deck so people have access to that. But this is just what this article talks about is what like React Native renderers are, and like sort of a little bit of how they work. It actually compares them to JVMs and how like Java was using JVMs like back in the day. And so right here you see a really nice layout of on iOS it's UI views, UI text, and Android is view groups and text views. And I just think this is just like so powerful and cool. And then at the right, you see that like it's a React Native any renderer. So theoretically, you can create a way to build React Native for any platform. And in the actual code, I thought that I would share this. You have the ability to select for one thing, see what OS you're on. So iOS, Android, web, but then render different things based on the platform you're on. So I've only showed iOS, Android, and web right here, but Windows and Mac OS are actually really new renderers that have come about. I can't speak to how stable they are because I think they're community driven. They're not like officially React Native. But to me, that's just like super exciting to see that come out and be like, man, like I'm spoiling a little bit, but like, hey, Ditto could like move to Windows or Mac OS in the future. Another point on this like platform thing that I think is really cool is that for actual files in React Native, if you name them with a correct ending, so if I'm creating a component called button, but I want a different button to be rendered on iOS and Android, then I could create one file called button.js and use this platform module, or I could do two files and name them button.ios.js and button.android.js. And then when I import button from plain button, it's sort of smart and it'll automatically choose the file for which the operating system currently is. So that's a really nice way to just like organize your code and really clearly see, okay, this is specifically for this. Something that I've seen that particularly useful with is that when I was playing around with potentially getting Ditto working for web, a lot of the navigation is different for mobile versus web. And some of the things we're using on mobile just straight up won't work on web. And so instead of basically like converting what we have to make it work, I'm going a different route where I'm keeping web in the same project, but at the root level. So all the way up the component tree, like at the very top, when it comes to like, hey, are we on web? I'm just rendering a completely separate like component tree. So it's this completely separate section of code that I can still use certain components, like especially UI components from the mobile side of things. But that means that I don't have to re-implement those, but I can do different things with like data, and I can use a different navigator. So I can have like a bar on the side with the messages in the middle, things like that. So that's just like, it's just super cool that I think we can do that. And that's sort of how that works. Let's go to the next one. Okay, so some people might mess with React Native and be like, this is super pain. Some things with React Native are just kind of quirky when you start out. You run into bugs that you've never seen in like Android Studio and Xcode, and especially if you're not a native developer. So I would not say I'm a native developer. I'm a React Native developer. And so when I was starting out, I found both Android Studio and Xcode to be like really intimidating. And I would see errors that I would like always have to Google because I had no idea how to fix them on my own. And so it can be a barrier for a lot of developers starting out. And so there's a tool called Expo. And a lot of people have been like confused by, oh, Expo is React Native, or like, are they mutually exclusive? Like, what exactly is Expo? So basically, Expo is a set of amazing build tools for React Native. It makes like the whole process really streamlined and smooth. You run into a lot fewer errors when you use Expo. So like if you're new to React Native, it's what I definitely recommend. It also has built-in web support. So if you have a plain React Native project, you have to do the work, and like the docs are great for it. So it's like, it's not super hard, but you have to do the work of adding certain packages and then making sure that it's building. Like bringing web into a currently existing project is definitely going to be more complicated than like putting it into a brand new React Native project. And so it's just nice that like Expo supports web out of the box. That is in beta, but I'm actually using it for a side project that I'm working on, and it has worked flawlessly for me. I am a big fan. Yes, also stupid easy notifications. Expo, so I'll explain a little bit in a second about like Expo managed versus bare, because those do have some significant differences if you're thinking of working with Expo. But the notification system with Expo is so easy because they host like essentially they talk to Apple and Android for you. So in your actual app, this is specifically for managed Expo apps, you can essentially just call like a post request to a URL that they have with a specific token that they give you. And it sends a notification to the device. So you don't have to mess with like setting up APNS or like Firebase cloud messaging in your project, because Firebase and React Native can be a pain. It just handles it for you, which is amazing. And then the last like point here is Expo Snacks, which is just like I say, in browser development for code snippets. So it makes it really easy to just prototype out things, see how it would look. And the in-browser development supports iOS, Android, and web. So you can see how your stuff will look on like all three platforms. Now, I also wanted to cover managed versus bare. So there are sort of three routes you can go with like using Expo and React Native. So you can have React Native as a totally bare React Native project. And you don't have to use Expo at all. It's just only React Native. Now, if you want to use Expo, you have two options. You can use managed Expo, which is an opinionated way to create a React Native project. It essentially means that you have access to all of Expo's libraries, and they completely manage like the build process. You can upload like your own certificates and things for actually building the APKs and like iOS apps, but like everything is within their ecosystem. And then the bare Expo project is kind of in the middle between these two. It means you can use certain libraries from Expo in your React Native project, but you have a little bit more flexibility with like how the actual project is set up and what you're doing with the code in the project. And then, so you might ask like, okay, well, so if Expo is so great, then like, why are you not using it for Ditto? The main reason is actually the lack of native libraries. So if you use a managed Expo project, what you gain in like stability and cleanliness and like just you know how it works, you lose in flexibility. So creating a React Native app, if you want the most flexible version, you choose a bare React Native app with no Expo, because there are certain NPM modules that will require you to do specific steps with the actual iOS and Android projects. And this is called linking with React Native. And the Managed Expo project actually hides those projects from you. And so you're not able to make those changes in the project. Now, you are able to eject a Managed Expo app and turn it into a bare Expo app. But in my experience, that has not been like the most stable process. Like, it's introduced some errors and stuff. I know they've just released like an update to that process though, so it might be better by now. But yeah, so when I was first like creating Ditto, I wanted a lot of flexibility in the types of things that I could do, because I had sort of this like basic starting point for like, okay, a chat app should be able to send messages back and forth. Step one. But then I was like, I want Ditto to be able to maybe do crazy things in the future. And I really didn't want to be limited by a choice that I made early on. So Expo is definitely great for people starting out, but it is a decision for apps that you are making. Like, you sort of want to look at all those factors and see if it would work for that particular project. Next, let's talk about user experience. So I will not like claim to be a user experience expert. I just read a lot about it. I'm very passionate about user experience because I feel like if you don't have good user experience, people aren't going to want to use your app, because there are other apps that like do focus on user experience. I will say that like an app that I particularly just like delight in using is Telegram. And I think about other alternatives. So like WhatsApp, Facebook Messenger, they're good and they work, but Telegram continues to like just pop up with, oh, wow, I didn't know it could do that. Or like, wow, that was really easy to do such and such. And so I really aspire to go that direction with Ditto and any other like chat clients that I make, because I think that attention to detail is what makes people really love your product. And so my next slide in this was actually showing Ditto, in case anybody had not seen the actual UI of Ditto. We are currently using a UI library called React Native UI Kitten. Oh, it's called UI Kitten. And the reason for that is because like building your own component library that feels cohesive and on brand is a lot of work. And I wanted to sort of get functionality in there instead of focusing so much on design at first. But I feel like we've done a really good job of keeping things like feeling cohesive, which I'm proud of. And I'll admit, like at this stage, oh no, go back. At this stage, I am focusing more on implementation just because Ditto is so new, but I really look forward to like the day when I can think creatively about things. I should have included this in my slides, but there were some designs that I had of Ditto way early on that were just like crazy ways of doing things that other any chat client, not just Matrix clients, weren't doing, where it was like I would have the menu bar on the side always visible with like avatars for each person, and just like stuff that once I tried implementing it, I was like, oh yeah, this is horrible. I don't want to use this. So that's why I sort of decided, okay, let's go with plain Jane. People know how to use this type of chat app for now. But yeah, so I love talking like just creative ideas. I love sharing like animations and micro interactions that just like make things just a little bit more exciting. So if anybody ever wants to talk to me about user experience, I'm all for it, because I think it's one of the most like important things in encouraging people to like use an app. Let's see. Next steps. All right, future of Ditto, aka Annie's lofty client dreams. First step, web. I'm very excited about this. I think probably 3 months ago, I did not expect this to be an option. And now I literally have like a very simple web version of Ditto running. It's not doing anything yet, it's just running. But it is very, very encouraging to me that like I was able to get it like going, because I didn't think I would be able to. So I just really look forward to implementing like the rest of that out, even at like a simple scale, because to me, it's crazy to think in my mind that like, oh yeah, like we have Ditto for iOS, Android, web, Mac OS, Windows, and then it's all in the same like code base. And so anybody could hop in, and if they know React Native, they could work on any part of it that they wanted, which is just crazy. React Native is so cool. Yeah, so there's that. That's a big next step that I want to do really soon. Another thing that's fairly new is I actually want to create a React Native like module for Matrix itself. I think Ditto is getting to the point where it would be possible for me to abstract some things out of like the actual code base that could be like able to be imported in other projects. And so people don't have to like struggle with getting the React Native or getting the JS SDK like working in React Native, because there are like a few like weird things that you have to fix. And they don't even have to like do any of the like hard stuff, like I don't know, persisting storage. They can just import it, and they can like render their own components for like room items, and it just works. That's a lofty dream. I will do that. I'm actually like kind of working on that right now, so hopefully that's soon. Someday I want voice calling and video chat. So that's on my list of like dreams that I want to do at some point. And then this is sort of showing like, this next point is sort of showing my wider vision. I really want a wide variety of clients, maybe even based on Ditto, like using that module I was talking about, but maybe brand new implementations with all stuff that I've like learned over like my time of working on Ditto. I want there to be like several or more, 10 or more, I don't know, really nice Matrix clients on the app stores. And so people will look at these and be like, what are all these chat apps that people are using? And then they realize that all these really nice chat apps can work together. And then their minds are blown, and then they use Matrix and everything is great. That's my dream someday. And then this was just a very like small thing that I someday want to do, is self-destructing group chats for like events. And this is just such a niche, random thing I want. But I plan a lot of events, and I want to just have a group chat where I make it and it deletes like after the event it has happened. That is just a personal, like I've just wanted that forever. So I'm gonna do that someday, and we'll see. And that is the end of my time. The end.
Brilliant. Thank you very much. Hopefully everybody got a good introduction to Ditto there. I can see myself. Now I can see you. Cool. Thank you very much. I've been following Ditto for a while. I know how excited people are about there being a React Native client, and people also just love the UI work that you've been doing. The first question: are you in an aviary? What's with all the birds?
Oh, sorry. So I can't hear anything outside of my headphones, so I didn't even know there were birds. I am actually outside of a Starbucks. Welcome to my office.
Beautiful. All right, cool. Sorry, it just had to be said just because people had mentioned it on the chat, and I thought it myself. So people have said that they really like the uncomplication of the Ditto UI, and I know that was a big thing. And then people have also pointed out that some of the ideas from Telegram are really good to take, like keeping users updated and educated on new features is really key. And I know that's something you've thought a lot about. Yeah.
Oh, I was just gonna comment. I do love the fact that Telegram has like basically a chat with Telegram itself in order to announce new features. And I've thought before about creating like this was an idea from a friend, but creating like a mascot for Ditto. And so when somebody signs in for the first time, they don't have an empty like chat list, but they actually have they have like a new message, and it's from like the Ditto mascot, and it says, "Hi, like welcome to Ditto." I think that could be really cute and fun. So.
Yeah, no, that's great. I mean, we see that a lot. Actually, Riot, I don't know if it still does. It certainly used to launch a new chat with RiotBot that had a sort of question answering component to it. But Telegram do it. Yeah.
I had a question.
So, what are your thoughts? Go on.
Oh, sorry, Ben. I was just going to say on the self-directing group chat stuff, that's actually a really interesting one because we have the MSC for it and the implementation in Synapse, but it's never been hooked up in Riot. So this could be a really awesome opportunity, hypothetically, for a Matrix client to get out in front of Riot and actually go and put the UI on it before we get round to it in Riot. So
oh my gosh, I'm going to do it.
Yeah, well, there are state events you can set there to literally limit the lifetime for returning messages in a room, and you could extend that then client side to self-destruct the room afterwards, and possibly we can do it on Synapse. In fact, I think Eric just volunteered to extend Synapse to add in the necessary retention stuff. So, and in fact, there are a couple of APIs which were done on Synapse, which were, I guess, done for specific clients, which aren't Riot, and we haven't got round to putting it into Riot, where there could be a real opportunity to go and put some of that. Also, there's some threading stuff, although I don't know if Amandine will kill me if I encourage other people to implement that before we get around to it in Riot. But suffice it to say that Matrix does have some basic threads, and it's even MSCs, but we just haven't hooked it up yet in the UX. So if you
at least we could compare UX on the threading thing if different clients have it.
Yeah.
All right, forget everything else. That's the first thing I'm implementing.
Sorry, Ben, I copied your question.
So we've actually got tons of questions, so I'm going to go down them in the order that I think they are most interesting. So we have a question here. What advice would you give to somebody starting a new Matrix client implementation today? Anything you would have done differently before implementing the CS API? And I actually had a related thing about like, how's your experience of the JS SDK been, which I think it ties into the same question.
Is that question specifically creating a new Matrix client for React Native or in general?
I would have thought it was in general, but I guess your experience is focused on React Native, so it's going to cover the answer.
I'll answer the creating a client, and then I'll answer my experience with the JS SDK.
Boom.
Oh gosh, that's a good question. So starting out, I would have probably like played with creating smaller, simpler clients a bit more first, so that because I don't learn super well from just reading docs. I learn from like doing things and realizing like, oh, this function does this and like this does this. And so I probably would have like done that and then set up a structure in the project for how I want data to be managed by the SDK I'm using. So for whatever SDK like this person wants to use. Because early on in Ditto, I didn't think that through ahead of time. And I sort of just threw stuff into Redux, which is a state management system, without really planning it a ton. So I think that's really valuable to know how you're going to persist data, because that's a huge thing for chat apps. And then how you're syncing that data with like what you're actually getting and like all of the live events that are happening. So that structure is important to think through early on, or else you're going to have a lot of refactoring to do. And then my experience with the JS SDK, after the first section of getting it to work with React Native. It's honestly been great. There were a few like just hiccups in the beginning where like, because the JS SDK is not built to work with React Native. It's built to work in like a browser environment. And so there were a few like basically substitutes that I needed to do for like browser things that React Native just needed to emulate. And then one weird ASCII kind of thing with a library called Homoglyph. Luckily, I figured out the problem and it has never been an issue since. So once I figured those like weird bugs out, then it has worked exactly how I have expected it to work since then. And overall, it's pretty understandable. And so I use like the JS docs for it all the time, and I'm happy with it. I wish there were more actual examples with it, like in other, I don't know, maybe I just need to find other projects or stuff or something. That's been the only thing that I've wished for.
We definitely need to do more. Oops, sorry, Emily.
Or you just ask Ben.
Yes, well, Ben is a resident JS SDK tutorial guru, but yeah, we probably could do more.
Yeah, I should be writing. Maybe we should be writing more tutorials. Yeah, there are a few sample apps, but yeah, there's never there can always be more documentation. In fact, I think we might lean on the upcoming Ditto SDK in order to create more of those examples. But so your basic answer to that is more MVPs and think more in advance about how to structure data, I think is the real gist of that one.
Yeah, those are the two things I would have done.
All right. Yeah, I mean, it makes sense. I mean, the thing is, and that's also, that can be an answer for almost any project, is those two things, I think.
Sorry, this was kind of a cop-out.
No, not at all. So, all right, here's a good one. And actually, I tried to get you to fight about this one on the Matrix Live last week. What are your thoughts on Flutter now that some other Matrix clients have popped up using it? That's a Noah's question.
Okay, so here's the thing.
Right.
Flutter's cool and all, but it doesn't have native components.
Okay.
So I honestly, okay, here's my like politically correct. I honestly don't know that much about Flutter. And also I tend to love Google products. And so like, I'm sure Flutter is like awesome. But the key differences that I know of is that Flutter doesn't use native components. And so I don't know much about the performance. I know the performance can be good, but I would tend to think that React Native would win in that case because it's using like the native operating system like pieces that it should be using. But like, yeah, that's what I think. Another thing is like, I don't know if Flutter has the capability for other renderers, but just like I was talking about with React Native, where there is now a renderer for like Windows and Mac OS. I don't know if Flutter's structure supports that. So if not, that would be a big win for React Native over Flutter. I think it also depends on what like the developer is comfortable working with, because like I've never touched Dart or anything similar to it. I don't know, maybe it looks like JavaScript. I've never seen it. But since I was already in React and React is such a popular library, I think it's really valuable that React Native like pulls so much of its syntax from that, because all those developers that have spent time investing in React can now use those skills in React Native.
Right. Yeah, no, that absolutely makes sense. We should have had somebody from Flutter on here to give a right of reply. Unfortunately not, so you get the last word. And I think you actually answered the next question I had, which was from Lub. He says, does it also compile to some native code, or does the JavaScript control the native UI elements directly? So the point is it renders to native components, I think.
Yes. Yeah, that is true. I think that is the answer to that question.
And then finally, is there a privacy concern with sending notification content through Expo servers, or is it possible to conceal information? We know that Ditto doesn't actually do this, doesn't send anything through Expo, I don't think, so it's not relevant to Ditto, but even so.
Yeah, so from what I've seen, it would be the same level of privacy concern as using APNS or Firebase messaging. Because I actually used managed expo project with notifications in this other side project I'm doing. And so from what it looks like, it seems like you could do the same thing that Riot does, where you only send the event ID and then you actually present it locally. Now, I haven't confirmed that that would work if the app is completely closed, because like one downside of JavaScript is that or with React Native is that if the app is completely closed, unless you have done some work with like background JavaScript processes that use like the native threads, you like literally can't do anything with the app because the JavaScript is turned off. So I would say that I'm fairly sure that that would work to just pass the event ID to that Expo notification service. And that would be the equivalent of doing like what Riot is doing with APNS and Firebase messaging.
Right.
Was that an answer?
Gotcha.
Okay.
It was great. So we have the question from Ms. Friedlander. Are you planning on using the React Native WebRTC library, and this is to implement VoIP? Will you be looking at VoIP implementation, or is this not on the roadmap?
So I definitely want to do voice and video calling in some client. Now, whether that is Ditto or not, we'll see, because I know that I want to implement more clients than just Ditto. And so I'm sort of in this place where like I don't know if I will like use a ton of the code from Ditto or be like, I've learned so much more, I could implement it better and differently now with something different. So while I don't know if that is if that is definitely on the roadmap for Ditto, it's on the roadmap for something I build eventually, but it's not soon.
No. I mean, it doesn't need to be a priority compared to everything else. So there's one more question. I don't know if this has been answered in the chat. No. Ditto on F-Droid. Is that something that could happen? So, yeah, about that. I think it's a React Native thing. It is. I'll go ahead and say it's not a priority for us right now. We attempted to put it on F-Droid like at the end of 2019, I think, but we actually just ran into a lot of errors with, I think, React Native. Now, I know that there are React Native apps on F-Droid, so there is some way to do it, but we just like couldn't figure it out and just struggled with it for longer than we probably should have. So we kind of put it on a shelf for now. I know there's one person in my like public Ditto room that was really passionate about it, and he was kind of like looking into it, but I don't know how active he like has been recently. So if somebody wanted to like pick that up as a project, I am totally open to it being on F-Droid, but it is not currently one of our like active goals.
Oh, I think we might have lost Ben, or at least high latency Ben. Or perhaps Ben himself crashed. You are back now. Welcome back.
I'm back now. Great. So yes, okay. But there are APKs available. So I mean, it's not. It's possible to avoid the Google Play Store, right? So if there's anybody out there who wants to help compiling Ditto for F-Droid and unblocking that, then please get involved in the Ditto chat. I think that's the end of our questions. So I want to say thank you very much, Annie. Thank you for creating Ditto, and thank you for appearing on Open Tech Will Save Us. Very, very interesting introduction.
Yeah, this was fun.
Annie.
Thank you. Finally, and you know, I said this at the beginning, but I think it might have got cut off. Eric is basically wearing the colors of the Ditto project. So welcome. Eric, I'm sure you will know if you're watching the stream, Eric is one of the developers of Synapse, and he has been doing some very technical work to allow it to run on multiple servers. So Eric, I'm going to hand over to you.
Cool. Thanks, Ben. Let me try and see if I can find my slides. Let's share my screen. Yeah,
slides in Dittos, so to speak.
Okay, can you see that?
Yep.
Cool. Right. Yeah. So basically, today I want to talk a little bit about like Synapse performance. Like we've been doing quite a lot of work recently, but also it's kind of been an interesting thread throughout all of like the history of Synapse from the very start. So yeah, I just wanted to kind of talk about where Synapse started and why we're seeing troubles and why it actually turns out to be slightly more complicated than we'd like to fix some of the performance issues, and also what we're going to be looking at going forwards and how we're kind of viewing it. So I mean, I probably don't really need to tell you why performance is quite so important as it is. If there's not a very if there's a lot of latency on the server side, that can have a huge impact on the way that people use the app. It can really add some like overhead when you're using it and make it sort of like just a little bit more difficult. And it can really undermine trust in the app and in the robustness of it. And you really want, for a chat app especially, for it to be really easy to use and you don't have to think about it. And you really want people to be able to trust that it's just going to work and not have to worry that, oh, it's taking 10 seconds to send a message and things like that. So performance is incredibly important. And we have viewed performance as important throughout the project. Now, some of you may kind of be heckling at the back there that, performance on matrix.org hasn't always been great. And really, to explain that, let's go kind of see what we've done and kind of how the architecture has evolved. So back when we first started Matrix, we thought, hey, maybe we should write a little proof of concept app to make sure that we're not completely smoking crack. And we sort of fairly arbitrarily chose Python to do that in. We thought it's probably quite a good, easy to write, easy to read. It's what the cool kids are using nowadays. This was back before Golang and Rust and things like that. And yeah, we kind of quickly hacked together an app or a backend server and an app that used it. And it was very simple. And this is the architectural diagram. It didn't even have a standalone database. It just used SQLite, but it worked, and it was enough that people could try it out. And like all good proof of concepts, it immediately went into production, where, of course, people started using it. And when you have users, people start asking for features. And when you have features, more users turn up. And when you have enough users, eventually things start to groan under the weight a little bit. And that's where, we hit the first bottleneck with Synapse, which was like SQLite, as great as it is, isn't really designed for what we're using it for. So we decided to stick a Postgres database on the side. And that's kind of doubling the size of the architectural complexity there, but it was quite a big step at the time, and that has actually lasted us for quite a while, just sitting there with a single Python process. We kept on adding features, getting new users, optimizing a bit, but quite quickly, it's starting to get a bit slow again. So the next big thing that we added was caching, and that's caching inside of Synapse. Now, caching in general is a really hard problem. It can cause all sorts of issues. But we thought, well, hang on a second. Synapse is a single process. It's got a single reader, a single writer. Like, there's no complexity going on here. When we write something to the database, we just invalidate the caches locally, and everything will be great. And that also worked surprisingly well and lasted us for quite a long time. Now, the interesting thing of caching in Synapse, unlike a lot of programs, is that it actually protects CPU as opposed to protecting the database. So, we were doing tons of duplicated work, especially pulling events out of the database, and deserializing would take a lot of CPU overhead, and things like that, and state resolution as well. To this day, it takes up a lot of CPU overhead. So caching all of those sort of stuff gives us a huge amount more headroom. But eventually that can only sort of do so much. And we started having to sort of think about ways, well, we can't just throw hardware at the problem, which is what we'd like to do, because it's a Python process, and you can spin up threads in a Python process, but thanks to the global interpreter lock, only one bit of Python can run on a thread at a time, which is a bit annoying. So it becomes almost single-threaded, even though Python is kind of running on different threads. So you lose out on that sort of ability to run in parallel, which means you have these big 24 core machines which you could run these really, really like large amounts of work, but they're useless for Synapse because it just sits there on a tiny little corner of the box on a single core. So it got to the stage where we're thinking, okay, right, we have to do something a bit drastic here. But at this stage, I don't know, a couple of years had gone past where this was working out fine. And during that time, we had baked in a lot of assumptions about us being a single reader, single writer little process. So we can't just spin up another Synapse instance and connect to the database and it will just work. No, things would just get very confused and go bang, and it would be bad. So sort of sitting there thinking, well, what can we do? And really the only option is to start pulling out some of the read APIs. And, because then requests can come in, they can just read from the database and everything will be fine. You don't have to write or anything like that. Unfortunately, we have this caching thing, which throws a bit of a spanner in the works, because you have all these caches that need to be invalidated whenever anything on the master process actually writes to the database. So when you're splitting stuff out of the master process, you also have to have some sort of intercommunication between Synapse and this other process to say, hey, you need to invalidate this cache. And so it ends up kind of looking a bit like this, where you have a bunch of workers and all talking to a Synapse process and a Postgres database. And this actually works surprisingly well, and it was surprisingly easy to do in some ways. The really nice thing about it is that the way that Matrix and Synapse in particular works is that you already have all of the kind of a pub sub mechanism. Matrix is a pub sub mechanism, so you can kind of piggyback on that to stream updates to workers. You have in Synapse, you have an event stream and you have a receipt stream and a typing stream, and they're all just sort of rows in a database table with an auto-incrementing integer, and so you get this kind of reliability for free on workers where if they get restarted, they can just go, hey, we got up to position X on the event stream, please give us all updates since then. So that's kind of really cool and really easy to do, and we can just keep on spinning more of these up, and because they're basically read-only, you can and don't really share much state with other ones, other workers, you can just keep spinning up more of these. They're quite horizontally scalable. I think at the moment we're running something stupid like 20 synchrotrons just to handle /sync on Matrix, and it kind of works fine. And yeah, like that kind of that architecture has lasted us up until like the start of the year, basically, where every time things got a bit slow, we'd find something new in the master process to move out and onto a new worker. So in the end, we've moved out things like sending over federation and handling login and registrations off of the master process and things like that. I mean, honestly, the big difficulty with it was that we have all this like really cool test suite for Synapse called SciTest, and it's kind of a black box thing, so it can run against different home servers. And now that we have kind of this indirection going on, you add some latency between a write hitting the database and a write actually being propagated to all the workers, which of course meant that you turn this on and you test it with SciTest, and like all the tests basically fail because they're assuming that events propagate instantly. So, and that's still biting us today, actually. Sometimes we'll do something and rejig some code in Synapse, and it'll give you a new race condition in SciTest, and you find a new flaky test which you need to go and unflake. But yeah, so this is kind of where we're up to today. But we still have this single Synapse process in the middle, which is just doing all of the writes, and that's not scalable. We can keep moving all the reads off, but eventually the writes are going to overtake how the amount of hardware we can put up this single threaded thing. So we kind of had to think, well, we need to do something drastic here, and go and think about sharding this master process. Now, sharding sounds like it sounds like a great idea, and it is a great idea, and it's something that we really want to do, but it's also something which fills me with slight horror. It sounds complicated, really complicated, and I'm not a fan of complicated things. at all. Like if I can avoid solving a complicated problem, I will do so. So we sort of sat down and thought, well, how can we do this kind of incrementally? How can we move something out of master without trying to do shard things? And eventually we realized, well, hang on a second, like we have these different streams that we're reusing, and while the master process does kind of assume that it's the only writer going on, where that assumption is actually it's assuming that there's only one writer per stream, because these are very decoupled. These streams are incredibly decoupled. Like you write to the event stream, that has nothing to do with writing to the receipt streams or the push rules streams or anything like that. So it sort of suddenly sounded naively easy to just take, you know, one of these streams and just move it over to another process. In reality, like it involves a huge amount of typing because you need to re-architect a bunch of different things. So in the code base, you ended up with lots of situations where you had a class if you're on master and a completely different class if you're on a worker. And so you needed to suddenly make sure that you could call various functions if you're on the worker that you were only meant to call when you're on master and things like that. But that's kind of fine. Like as much as I hate typing, I much prefer typing over the thinking and complicated problems. So we're like, okay, right, let's try this. But before we could do that, we have to face the problem that currently our replication architecture looks a bit like this, in terms of we have a single master process, and each worker connects directly to the master process, and the master process just shoves lots of these updates and various bits and pieces down these TCP streams. Like every time it writes the database, it will send those updates down these replication streams to make sure that the workers are notified that stuff has happened, and caches need to be invalidated. But you know, suddenly, like, hey, if we're moving like writing to a different process, then suddenly these other processes and these other workers need to be able to write to the replication, and that's not supported in this kind of topology that we have, the star topology. So we have to figure out what to do here as kind of like step number one. And we sort of had all sorts of range of ideas like, hey, why don't we just talk to the master process and have the master relay to everybody else, and things like that, or maybe do full mesh. But all of this kind of felt, it's surprisingly expensive to write down these replication streams in Synapse and in Python. Like I think at peak, like 15% of the CPU on master was involved in just writing updates down to these streams, and that was only with like 15 workers connected or something. So it didn't even feel scalable to do for like full mesh or continue with the star topology. But thankfully, it's no longer like 1998, and we don't have to do our own custom weird TCP protocols for PubSub. We can actually take something off the shelf. There are PubSub servers out there that will do what we want. So that's great. We can go and have a look at things like Kafka, but eventually we looked at Redis and decided that Redis being really simple, it doesn't try and do anything hard, it doesn't have any persistence, so it's really easy to run. That sounded like the right fit. And actually we realized, like, hey, why can't we use Redis as not so much necessarily like high-level PubSub mechanism, but can we just use it as almost like a dumb transport? Like we can take our existing replication protocol traffic and just, instead of shoving it down individual TCP streams, can we just shove it into Redis and that will just work? And actually, shockingly enough, just with a little bit of rejigging of the replication protocol, it does work. You can just shove a Redis in the middle, and it works pretty much the same as in the old way of using direct TCP sort of star topology replication connections. And this is quite cool because it gives you the ability to support both ways of running replication, in terms of you can keep using the old direct TCP connection style thing in newer synapses, which is really great because like it means when you upgrade Synapse, you don't have to have the entire world that's using workers suddenly have to also upgrade to a Redis. It gives people some time to move over, it gives us some time to test Redis, and not just, turn it on and have to roll back the entirety of Synapse. If it turns out to blow up, we can just turn off Redis in a config option. So that's really nice. And actually in future, we are planning to deprecate the TCP replication stuff, but for now it's fine. And yeah, we turned it on, and predictably enough, it sort of worked for about 15 minutes before we got weird reports of stuck messages at the bottom of screens and things like that. So we had to turn it off and figure out where all these bugs were coming on, fix them, turn Redis back on, find some more bugs, turn it off, and repeat. But eventually we fixed all the bugs, and matrix.org is now currently running with Redis. Now, the cool thing with this is suddenly like, this diagram suddenly looks a lot more symmetrical. Like, what is the difference between these worker processes and this master process? And this is kind of crucial because throughout all of this work, we've sort of gone from making master special and these workers a completely different app to kind of more and more blurring the line. So actually, you end up in a situation where you don't have master and workers. You end up with just workers. And the only differences between them is config options. But yeah, so that's kind of the aim. But we got this, and we got this position of, right, this works. Now we just want to try and airlift, say, event persistent writing off to a separate worker to see whether that will just work. Just not trying to shard a stream or anything like that, just move the writing to a different worker. And we did that. And it seemed to work in my little tests of writing, and I came to run it against the test suite. And it all blew up because, predictably, caching has come and bitten us in the ass again. Who knew that caching is in fact hard? Because, like, when I said a few moments ago that all these kind of streams, these replication streams, are kind of disjoint, like the event persistence and the typing streams and the receipts are completely disjoint and don't have any kind of dependencies. That's no longer true when you think about the caching validation stream, because hey, when you're like writing an event to the database, you need to invalidate some caches, and when you write receipts to the database, you need to invalidate some more caches. And hang on a second, if we're writing receipts from one process and writing events from another process, does that not mean that we have to write to the cache and validation stream from both processes? And like with dawning horror and like terrified realization, like you suddenly realize, like, hey, we're going to have to figure out how to do this complicated sharding of streams actually up front. We can't do this halfway house of just moving stuff off master. That was a bit of a nightmare to realize. But thankfully, coming in the next morning and giving it a bit of thought, we realized that cache and validation is actually a little bit simpler than some of the other streams. The nice thing about cache and validation is that you don't have to persist it in the same way as you do with other things, because if your worker restarts, you don't have to fetch updates from the cache and validation stream because all your caches are empty anyway. There's nothing to invalidate, so there's no point getting them. And the second is that it's only doing a very small thing with the cache and validation stream. It's just taking updates off it and then invalidating the cache, and that's it. It's not caring about the order of the updates. It's not, all it wants is reliability. Everything else it doesn't care about. So you can actually do something like we do for the sync streams and the rest of it, and actually just do a vector clock and go, well, maybe we can, when we write to these streams, we can just include an instance name and an instance ID of the instance that wrote it. And when these workers read off these streams, you just go, oh, okay, right, I'm up to position X on worker A and up to position Y on worker B. And if you restart or your connection drops and you need to reconnect, you can go and fetch updates based on those two different positions. And you just have to track positions of every worker that's writing to the stream. So it kind of went in 24 hours. It kind of went from everything's awful, this is 20 times more complicated than we thought it was going to be, to, oh, okay, it's fine again. This might actually be fine. So a bunch of typing later, I had a prototype of writing to caches from various streams, and that worked, and got it merged in to develop. And went back to my old branch of event persistence off master and merged that in, and then tried Cytest again. And it mostly worked. Tons of tests failed due to new and exciting race conditions in the tests, but for the most part, it just worked. which was really awesome. And finally, it got to the stage where all the PRs had gone through, and we landed it on on mainline. And I think on a Tuesday morning after a bank holiday, we're like, let's deploy this to matrix.org and see what happens. I was kind of expecting to have to turn it on like we did with Redis and then immediately turn it off as we find all sorts of bugs. But actually, it kind of worked first time, which was deeply satisfying. And especially when, a few hours later, when we got to look at the really pretty graphs. And this is what happened when we split out the event persistence. So the top graph is one Tuesday. I apologize, it's not last Tuesday and this Tuesday. I stole this from a Twitter.
Sorry, that's my fault. I should have put the dates on it.
Yeah, well, no, yeah, I could have just actually fished this out from Grafana, but I started battling my Linux to try and take screenshots, and it turned into like 2 hours of trying to fix that. But anyway, yeah, so the top one is this is event send time, and you can see that once the CPU saturates on master in the old style system, it starts to take seconds to send messages. This is a logarithmic graph, by the way, and I'm also pointing at the screen, which is not helpful. There we go. So like you can see, like it just takes forever to send messages, like really consistently forever to send messages, which really sucks. And this happens every day, kind of during the day. It wasn't just a one-off event. But when we come to turn on event persistence, you can see like, hey, all of these message send times suddenly drop. And you can see at the same period, we don't get this peak. We just get this really nice, lovely, like hot bit at the bottom, and it's only taking like 25 to 75 milliseconds to send these events and respond to them. There's a little bar of it, 100 mils for like some of the bigger rooms, but for the most part, really great. So yeah, that was really deeply satisfying. Though I did have a look at the graphs earlier today, and it turns out for some reason they're going slow again, but we're going to ignore that for now. But yeah, so we landed that, and that's great. And it kind of got to the stage where, like, hang on a second, like now after we've cleaned up all the mess that we made rushing this out, where do we go next? Because like we've gone through this and made event sending time faster and reduced the master CPU usage a lot, but I mean, that's what we needed to do. But now, where do we sort of focus next? Because event sending is one small aspect of the system. It's an important aspect, but it's a small one. Do we go and focus on making fetching media quick? Because at the moment that's quite slow. Or do we try and make the end-to-end encryption APIs quick? And we ended up having this meeting and kind of thinking about the different focuses that we could have, and we kind of decided that they're kind of some different focus areas. So we could spend some time focusing on making matrix.org just go faster and improving all the response times there, and that would really help sort of the project as a whole, because matrix.org won't completely fall over all the time, and it will help other larger deployments maybe. Or we could start looking at some of the other, like some of the modular hosts, for example, to see where they're taking all their time to try and help improve performance for different types of servers. So different, because you'll have different use cases for different servers, and they'll have different profiles, and some may be bottlenecked on some things and others on others. So that's one thing that we could focus on. Or another big thing is just making like the home service easier to operate, because I know a fair amount of ops now. I'm mainly a developer, but I'm on call and things, and so when things go bang on Synapse, I will go and poke it, and because I'm a developer there, I know all the knobs to twiddle, and I know how it works, and I can look at these Grafana graphs and put my finger in the air and think it's probably going to be this, and make educated guesses, and generally that will work out. But most people aren't Synapse devs, so you want to maybe look at making these things easier to operate, which means things like make everything shardable, so that if you do have a performance problem, you don't need to go and tune caches or anything. You just spin up more instances, and then you're done. And then maybe you come and complain at us for poor performance, but at that time, at least your response times will be down. And then kind of the other thing is looking at, well, things like making it easy to tune your caches, or even looking at making your database sizes, making Synapse use less database, both in terms of size and in terms of I/O and things like that. So that discussion is kind of ongoing, but those are kind of some of the things that we're thinking about. And yeah, so we'll probably focus a little bit on everything, but probably quite a lot on matrix.org for now, but we'll see. And yeah, that's basically all I had for today. Yeah, thank you.
Brilliant, thank you. That's quite a lot, actually. To have done all that work.
I have no idea when I started because my phone started buzzing on the table, so I had to put it away.
Oh no! I just meant the amount of work and the everything you've done. So, sorry, I can see myself and only me.
Yeah, no, there we go.
So we had not too many questions. I think people are just basically very excited about the matrix.org performance. We love the slides. It was a lot of fun. You've obviously got some nice paper that you've been working on in lockdown. One of the more interesting questions: why PSQL? Why did you choose that initially?
SQLite. Yeah. So that's so it's kind of actually what I was meaning to talk about at some point. But one of the really nice things about SQLite is because it's bundled in process. It means that you don't have this external dependency. So actually, when you use SQLite, all you need to do is download Synapse and press go. You don't need to like set up a database, and you don't need to make sure that it has the right encodings and languages and the rest of it. It just kind of, you download it, you open some ports, and you press play, and voila.
And for Postgres was the other one? Like why Postgres as opposed to MariaDB over?
I threw a slight wobbly when initially.
What's a wobbly for our international viewers?
A small tantrum. So basically, I started implementing it for MySQL, I think, or MariaDB. Well, it's so long ago now. And you run straight into the problem that we were storing JSON in sort of UTF-8 rows or columns, and I think at the time, like by default, the UTF-8 type only was 3 bytes wide maximum. So if you put in emojis like 2 bits clinking together, like the entire thing would explode in a ball of flames. And like little bits like that, which were just really, really annoying. And so, yeah, I think I threw a bit of a tantrum and tried Postgres instead, which doesn't have quite such so much silliness going on. Which, yeah, basically, I mean, it's kind of like we had to choose one or the other. And yeah,
we did get quite far though through the
absolutely.
MySQL fork though, as in there is still, I think, in GitHub a fork with MySQL support for Synapse before Eric's wobble, and it got thrown away because we were entirely a MySQL shop before that point and knew how to admin it and do replication and had all of our backups and high availability stuff. So it's quite a radical thing at the time to shift over to Postgres. Yeah. But I don't think we regret it at all, honestly, in the end.
No, although it backfired slightly because suddenly I had to become a mild expert in how to manage one of these Postgres things.
Well, I think that was literally what I said. Okay, Eric, if you really want to do Postgres, go for it. But you get to do all the replication work.
Oh, God. Yeah. But no, I mean, the thing, actually changing it isn't too bad. It just means going through and changing lots of SQL. At the time, we didn't use quite such silly SQL queries as we do now. So it wasn't too bad, if I remember correctly. So, yeah. And Postgres has been great. I love Postgres.
So I had a question about sharding, and when we get around to actually sharding the master, is this sharding by room or by event or by whether the number's odd or even or what?
It's almost certainly going to have to be by room, simply because we have tables like the current state event tables, which are basically they're tables that for a given room, this is the current state. So if you're trying to write to the write events to the same room from different workers, actually making sure you get the current state events table correct is quite difficult because you need to do state resolution across extremities and the rest. So it's not something like you just use a particularly complicated upsert. You would need to probably like import some Python into Postgres and run that, which is, you know, something I've been avoiding doing, as much fun as it would be to run parts of Synapse in Postgres as a fun function. So it would be by room, I think. There's some really interesting kind of thoughts about exactly how we tackle this in terms of the big things with that is how you route. And when you add a new worker, for example, how do you get some of the requests on there? Do you just take a massive global lock and like remap everything around and things like that? And whether you just need to take the entire servers down, add some stuff, change the config, and then take everything up. It comes down to how far down the route of auto scaling do we want to go.
Makes sense. I got another question actually. Oh, sorry, Ben.
No, so just on that front of how auto it could be, Lub's asking, is it planned that you would just spin up generic workers plus Redis plus Postgres and a load balancer, and then whenever you want to scale, you just add more workers? Is that
that's the dream? That's kind of like the high level end goal, and kind of basically what we kind of want to work towards. I don't think we're going to overly focus on ensuring that we get there in particular anytime soon. What we'll probably end up doing is making certain endpoints shardable, and then you just have like, hey, actually all these endpoints need to go to their own dedicated box, but everything else you can shard. And
exactly. So I think his question was around the simplicity. Like, is it just going to use the existing home server.yaml? But my guess is that if you're in the need to start sharding Synapse, then you probably are going to be doing some other DevOps work as well.
Yeah, I mean, so at the moment you have to have a config file for everything you spin up, and some bits and pieces. I mean, now that we have a Redis in play, like suddenly we can start adding some stuff to Redis. So when you spin up a new worker, you could be like, hey, actually, let's just store the routing information in Redis, for example, would be an obvious thing. Yeah, so I mean, this kind of comes back to like making the whole thing easy to operate as possible by someone who doesn't really know how to run a Synapse kind of thing. It's kind of one of the focus areas. Whether we actually end up focusing on it sooner or later, I don't know.
Understood.
I had another question, which was not about sharding, but about caching, because a lot of the talk has been all about the caching. And this is, I guess, a question for new home server implementers. And that includes Dendrite, because last week, the Dendrite guys got to the point where they need to start implementing caching in Dendrite. And Dendrite was always designed to not require caching and to keep things as simple and stupid as possible, that you could just pull it straight out of the database, and it would be unusual to have to cache those results in RAM. But they finally got to the point that with enough real traffic on the network, particularly I think for caching the keys of other servers, you don't want to keep pulling them out of the database every single time you want to check the signing key for a given server. So they started to add caching, and then there was, I wouldn't say a fight, but certainly a moment of debate between Neil and Keegan, the two Dendrite developers, as to what caching should look like in Dendrite and what they should learn from Synapse in terms of what is good about Synapse and what is bad about Synapse. And in fact, this ended up being written down as bug 1102 on Dendrite, which I'm just going to check into the chat room in case anybody is interested, because it's this massive chunk of markdown that Neil Alexandra ended up putting down, which covers questions like, should we even be caching in memory, or should we be caching everything in Redis so it can be shared between the different components? And should we cache mutable data, or should we only cache immutable data? Should we have multi-tiered caching? And it just goes on and on and on and on. And my question to you was, if you were doing it all again, what would you do differently with the caching in Synapse? And is caching really as disastrous as it sometimes feels like it is in Synapse?
I think we'd probably do it probably similarly if we were in Python still. Like, I would definitely rewrite a bunch of it to be less error prone, and make it easier to like, currently we don't necessarily, every time we invalidate a cache, we don't necessarily write it down streams. So that's often a foot gun, and it can be quite hard to figure out when you need to invalidate caches and not. And trying to do something around that to make that a lot more obvious and less error prone and less kind of done by hand would be good. But the problem with Python in particular is that you can't do it off process because there's very little point. It's all about trying to save that cost of pulling it out of the database in the first place. So you could do maybe some things like some state resolution stuff, maybe. But for the most part, I think in process is the way to go.
So you're saying that if you had just a blunt event cache of all the JSON, of all the events which your server has seen, the overhead of pulling them out of Postgres' in-memory query cache is probably, it might even be worse than pulling it out of Redis's in-memory cache?
Well, I mean, it's just that it wouldn't save anything on Synapse. So, like, at the moment, I mean, I think we probably at some point do want to look at some caching to protect the database from thundering herds. But right now, it's all about saving that deserialization cost from JSON into in-memory format of events. So, yeah, I mean, if I wasn't writing in Python, I would be a lot more tempted to do it off process as much as I can. Maybe like immutable stuff in process makes sense, and maybe having a small cache in there. But in some ways, the big problem with caching in process is the configuration. Like, there's a big problem that we have today is that if you get the configuration of your caching wrong, like the wrong cache sizes, your CPU blows up and your memory blows up and everything's awful. And it's not obvious it takes a lot of time, even for me, and I know it back to front, to tune matrix.org. And I do it every now and again, but it's like a day-long process of fiddling with things and looking at how fast caches sort of grow and when they hit their max size and things like that. And it's an incredibly tedious process and needs a lot of knowledge. And I think that's a huge problem because people outside of the team can't really do that. And so how do you operate so that sort of Synapse and the caching stuff when you're not me, basically?
And that was going to be my other question. When are we going to put auto-tuning caches into Synapse so we can get rid of Eric in the nicest possible way?
Yeah, I mean, it's the weird thing. So this kind of goes back to an interesting debate that we had ages and ages ago about things like expiring items by size and expiring items by time. And what we do at the moment is almost always by LRU cache, so by size. So you have your cache of 1,000, you only have 1,000 items in that. The really nice thing about that is that it has a relatively stable memory profile. So you're never going to worry about getting a huge amount of traffic and suddenly there's going to be a massive spike of memory that you're just going to hold on to for ages. Because if you have expiry times, you get, if you have 5 gigabytes of traffic going through over a 5-minute period, then that's what your cache size is going to be, and you might not have 5 gigs to spare. But on the other hand, in some ways, expiring caches are, to a certain extent, auto-tuning because, of the nature. So how exactly we do this? I'm tempted to just add a knob that lets you turn everything onto an expiring cache. There's a fun issue somewhere in the Synapse one of doing fun things with Bloom filters to count what your cache hit ratio would be if your cache was bigger or smaller, which involves looking at all sorts of new papers for sliding window Bloom filter counter things. But that's a bit more pie in the sky thing because it involves writing new Bloom filter implementations. But it would theoretically allow you to have Grafana graphs of if your cache was 50% smaller, what would your cache hit ratio be? If it was 100% bigger, what would your cache hit ratio be? And so you wouldn't have to spend all that time staring at graphs. You could be like, okay, if I double this one, then your cache hit ratio goes through the roof. If I lower this one, then I get the same. So it's that one's too big, that one's too small. Done. And that'd be really cool.
It's basically auto-tuning in the end, right?
Yeah, and you can make it auto-tuning. But the problem, of course, with caching is it's on the hot path almost by definition. So if you're adding all sorts of fun computation in there and statistics, you need to be fairly damn sure it's going to be fast. Otherwise, you're just going to end up being slower than if you just pull things out of the database in the first place.
Sorry for monopolizing questions about caches. Ben, what else do we have?
No other specifics for Eric. Just a lot of gratefulness that it's all going to be so much faster. I think we're coming to the end. So if I'm just going to give a few seconds in the chat if anybody wants to say anything. But apart from that, it's just to say thank you, Rabble. Rabble's on the West Coast. I think he's probably gone back to work. Thank you to Annie for giving a great presentation on and an introduction to React Native. And thank you, Eric, for both doing the work and presenting all the work on the performance improvements in Synapse. So thank you to all. Hope you enjoyed Open Tech Will Save Us #3. Bye.
Bye.
Thanks, Ben.
Thanks, Ben.
Bye.
Bye.